Short-circuit forces, stress, deflection, resonance, introduction. When a short circuit takes place, forces are generated uniformly along the length of the conductor. The conductors are bolted or clamped onto insulators. The insulator, in turn, is bolted to the supporting member. It is the normal practice to provide a cushion in the interface between the conductor and insulator, or insulator and supporting member, or both. When the force acts on the conductor, it will yield. Fiber stress must be limited to a value within the yield stress, with a safety margin, to prevent the conductor from experiencing permanent deformation. In a busbar system, the conductor is supported or clamped by many insulators along its length. A conductor supported on 2 insulators, or 1 span, can be approximated to a simply supported beam, whereas if it is supported with 3 or more insulators, 2 spans or more, then it can be approximated to a continuous beam. Short-circuit generated electrodynamic forces on the busbars is considered to be a uniformly loaded beam with multiple supports. For the solutions to such a problem, the theorem of 3 moments is applied. It can be established that the bending moment, fiber stress, and deflection arrived at above for a simply supported beam are higher than those for a continuous beam. The reaction at the supports of a continuous beam is higher than that for a simply supported beam. For a 3-support beam with 2 spans, the reaction in the middle support is 25% more for the continuous beam than that for a simply supported beam. The maximum internal moment and reaction force occurs when the beam is supported on 3 insulators. The reactions and bending moments are detailed in Table 7.5. For a beam that is supported at either end and with uniformly distributed load, the formulae detailed in Table 7.6 are applicable. It may be noted that 1. Maximum deflection occurs in end spans and is more than that for a continuous beam of 2 spans. 2. Maximum moment and fiber stress for simple beams occur at the center of the span. 3. Maximum moment and fiber stress for beams fixed at both ends occur at the point of support. 4. Maximum moment and fiber stress for continuous beams occur at second support from each end. The table displays the units in MKS and FPS systems for the following: deflection, load, total uniform load, span, modulus of elasticity, moment of inertia, bending moment, section modulus, fiber stress, maximum allowable fiber stress. A conductor supported by a set of insulators at reasonably regular intervals will deflect on the application of a force. On a short circuit, the force will have an oscillating frequency corresponding to the system frequency and double the system frequency. It will be 50 and 100 cycles per second for a 50 Hz system. It will be 60 and 120 cycles per second for a 60 Hz system. Any beam supported at its end will have a natural frequency of vibration which is based on its moment of inertia, span, and modulus of elasticity. If delta is the deflection in the middle of the span due to its own uniformly distributed load, then as a thumb rule, for any given structure, the natural frequency of vibration in cycles per second as a function of deflection delta in millimeters is given by the equation. The natural frequency equals a constant k, divided by square root of delta. K equals 18, when the deflection delta is expressed in millimeters. K equals 3.52, when the deflection delta is expressed in inches. It is necessary to ensure that the natural frequency of vibration does not resonate with the forced vibration induced by the short-circuit forces. For a given geometric shape and material of busbar, the only variable parameter to control the natural frequency is the span, which should be designed to avoid resonance. Following thumb rule may be followed to stay clear of resonant conditions. For the 50 Hz system, range of natural frequency to be avoided is 40 Hz to 60 Hz. And 80 Hz to 120 Hz. For the 60 Hz system, range of natural frequency to be avoided is 50 Hz to 70 Hz. And 110 Hz to 130 Hz. Thank you. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to Bala at busbarsystems.net.